Well, welcome back to Scripture and Science. We're in session 8. And in the last two sessions, we took a brief look at modern physics, especially as it relates to the Big Bang. And then we focused on how do we relate Genesis 1 and the Big Bang together. We looked at several different options for relating Genesis 1 and the Big Bang. And in this session, we're going to talk about fine-tuning. Now, as I mentioned, I have a master's degree in secondary education and spent a couple of years teaching. And as a former educator, I am not supposed to have favorites. You're not supposed to have favorites. I'm also a dad now. You're not supposed to have favorites, right? With your kids. But this session is probably my favorite session in the whole class. We're going to talk about fine-tuning. I just think fine-tuning is amazing. So what are we going to talk about? We're going to talk about what is fine-tuning. Some of you may have heard of this, some of you may not. So what is fine-tuning? Then we're going to look at many examples of fine-tuning, and it's going to seem probably like I'm just machine gunning examples at you. And I got to tell you, I left a ton of examples out. So if you want to know more, there are several resources that I'll give you in this session to where you can look into this concept more. It's a lot of fun. It's fascinating. So then we're going to ask the question, what does fine-tuning say about the existence and nature of God? Which is also a very interesting question. We're not going to have a ton of time to focus on that, but I'll leave that as possible homework for you. So what is fine-tuning? What is fine-tuning? Well, simply put, fine-tuning is the idea that the existence of life on Earth is due to remarkably precise settings in the natural world. So one thought experiment you could use is imagine the moment of what we've been calling the Big Bang, the creation moment itself. And imagine that God has a machine in front of him that's going to generate the universe. And there's all these dials and knobs, and there's all these different things. And the idea of fine-tuning is that some of them, there's a wide range of possible outcomes. God could just, he could twist the dial almost to a random number, and the random number would have possibly worked fine. But there are several examples of dials that just, if you imagine like 360 degrees, sometimes on dials you have the little marker where it's like, this is where you need to put the dial. Well, that's where God needed to put the dial. That's exactly where it needed to be put. If it's put anywhere else, we don't end up here having this conversation talking about Scripture and science. So that's sort of in the background of everything we're going to talk about in this session is what were the initial conditions of the universe? How do we get to the point of having habitable life here on this planet? So here's maybe an example that's more relatable than God having thousands of dials. Imagine we're baking a cake. And if you've baked a cake before, you know that baking in some sense is chemistry. There's some chemical reactions that undergo when you're baking cake. But in modern times, it just mostly happens by you buy a mix, you put a couple things in that mix, you throw it in the oven, and usually things are fine. Well, imagine instead of that normal mix setup, you're doing the mix yourself. And imagine that if you're baking a finely tuned cake, imagine that you have to have exactly 10 grains of salt. 9 grains of salt, the cake falls apart. 11 grains of salt, and the cake is rock hard. But 10 grains of salt, that's the exact amount of salt you need to make this cake just the right way. That would be a finely tuned cake. And we'd say that salt is the finely tuned characteristic of that cake. Now, maybe the flour's not finely tuned, and maybe the eggs are not finely tuned. But that salt, by golly, you've got to have 10 grains of salt, or else that cake's going to be a mess. That's the difference between baking a cake, which is not usually that stressful, and baking a finely tuned cake, which is a little bit more high stress. The classical example of fine-tuning, which was forwarded by a man named William Paley, is imagine you're walking through a forest and you stumble across a watch. Well, what do you think? Do you think that watch just evolved there over time and you just happened to come across this watch in the wild? No, the watch has indicators of design. You would think, oh, someone lost their watch. And so when we look at the universe around us, scientifically, do we see a watch in a forest, or do we see blobs that could have come into existence on their own? That's the question we have to ask ourselves. This is a scripture that we looked at earlier in the class, and I think makes this point about fine-tuning in a very interesting way. In Romans 1, verse 20, in the ESV, it says, "For his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world, in the things that have been made, so they are without excuse." Now, in this text, Paul is not talking about cosmological fine-tuning or the properties of water or carbon or beauty in mathematics. He's talking about you just go out and observe the world as it existed 2,000 years ago, and there's enough evidence for God's existence just in walking around that you're going to see that God exists. What we're talking about here is like an amplification of that. It's saying with modern science, all the details that we understand about the universe around us, there's even more reason, I think, to believe in the existence of a God, and specifically the Christian God. So we're going to look at three categories of fine-tuning. Cosmological fine-tuning. We're going to look at the properties of carbon and water, sort of chemical fine-tuning, I guess you could say. Then we're also going to look at beauty in math, physics, and nature. Our first example comes from the balance between the forces we observe in nature. There are four main forces that we observe in nature. It's not earth, water, wind, and fire. Those are not the four main forces. We're talking about the strong nuclear force, the weak nuclear force, the electromagnetic force, and the one that we're probably all the most familiar with, which is the force of gravity. Force of gravity is what keeps me in this chair instead of floating around the room or something like that. All right, so it turns out that the balance between these forces, if you could think about these knobs at the beginning of the universe, these knobs had to be set in conjunction with each other. The balance between these forces had to be just right for our particular physical world and universe to exist the way that it does. I'm going to give just a couple of examples, but there's many of them. For example, a 1% change in the strong nuclear force would have a 30 to 1,000-fold impact on oxygen and carbon production in stars. So if you move it a little bit one way, you end up with all oxygen. You move the other way, you get all carbon. You don't get the right balance that you need for life. This one is also interesting to consider. Small changes to gravity would make large life impossible. So imagine if gravity was slightly more impactful than it is right now. Then like giraffes couldn't exist because they couldn't pump blood to their brains. And so it's just amazing to think about how these forces are balanced together. The balance between gravity and the electromagnetic force allows for gentler yellow stars like our sun. If they were slightly less balanced, you'd end up with only stars like red dwarfs, for example, that would not be hospitable to life. So just to get yellow suns, yellow stars like our sun, you have to have gravity and electromagnetism pretty finely tuned to get to the point of having stable stars that provide gentler rays. Here's a great quote from a physicist named Martin Rees. He's not a Christian. He's a skeptic. And he says, "The expansion speed, the material content of the universe, and the strengths of the basic forces seem to have been a prerequisite for the emergence of the hospitable cosmic habitat in which we live." So this is evidence from someone who disagrees with some of our worldview as Christians. And he's saying, look, there are things about the universe, including the strengths of the basic forces, as we've already talked about, that seem to have been prerequisite for the emergence of hospitable cosmic habitat in which we live. So this is great. We have a skeptic saying, yes, this is what it appears to be. Now, there are answers to fine-tuning, and we'll get to those answers to fine-tuning. Why doesn't fine-tuning lead everyone to believe in a God? Well, we'll get to that later in the session. So that's a little bit about the balance between the forces. Now, my second example on cosmological fine-tuning is the balance between other quantities. The first one is the proportion of hydrogen converted to helium. If the proportion was slightly off one way, you end up with too much hydrogen. You go the other way, you end up with too much helium, and then you don't get the advanced fusion reactions that you eventually need in supernova that you need for bigger stars, denser stars, and then eventually get you to planets and that sort of a thing. What's also interesting is it appears that nuclear physics, the study of nuclear physics, it seems like it's precisely designed to produce enough carbon to support life. Carbon is incredibly important, as we're going to see later in this session. We have to have carbon to have DNA and RNA and to have the building blocks of life. And it turns out that the way that all these things work together, the way that our nuclear physics works, is finely tuned to produce carbon in enough quantities to support life. And again, as an aside, and we've talked about a lot of things so far, but none of these things had to be this way. There's lots of possibilities. There's nothing, we haven't found any guardrails in science that says, hey, these things had to be within this little tiny range instead of what looks like an infinite number of possibilities. There's not a lot of guardrails out there on these things, scientifically speaking. So that's just very interesting. So these are not light examples. These are very weighty. How about the existence of supernovas? We've talked about how over time as the universe expanded, it appears that stars were very light and that over time they eventually supernovaed, and that massive amount of energy led to new elements being formed, provided the ability for these chemical reactions to work in space, and eventually you get to heavier and heavier stars, and then eventually you get to planetoids and asteroids and things like that. Well, the existence of supernovas is directly responsible for that. That's what leads to second and third generation stars. And those are the stars capable of supporting life and producing the elements that we need. We need a ton of different elements on our Earth to support our function, to support any other life function. I think there's like 27 essential elements that we require to survive. And to get those elements, to fill out that periodic table of elements, you've got to have supernovas. So that seems to be finely tuned. This is a wild one. There's a very specific variable that scientists call the phase space volume. And it appears to be finely tuned to 1 part in 10 billion to the 123rd power. So that is 1 followed by 10 to the 123 zeros. So I don't even know how to put that number in perspective for you. There's no way to make that number make sense. It's more, in colloquial English, it's impossible for this universe to exist the way that it did without fine-tuning. That dial for phase space volume, there was one spot in 10 billion to the 123rd power. There was one spot, if you think about like a circle and splitting it up to an infinite basically number of spots, there was just one tiny little notch that could have worked for that specific quantity. Another thing that's really interesting is the expansion rate of the universe seems to be perfect for life. We've talked about how with our Big Bang model, the universe expanded and it cooled. Well, at some point, it started accelerating its expansion again. And that's important because if it hadn't done that, our universe would have headed for what they call a big crunch. It would have collapsed back in on itself. And so because of that mechanics, scientists have postulated the existence of something called dark matter and dark energy. And so the expansion rate has to be just right because you have to get, like I said, you have to get these dense pockets of elements. You have to get these dense supernovas. You have to have nebula. You have to have all this stuff happening. Then eventually this stuff spreads far enough apart out, and eventually the gravity would make it come back together. You would think it would make it come back together, but there seems to be something pushing further out and expanding it further. Well, even though we haven't observed directly dark energy and dark matter, and there may be theoretical restrictions on that, the amount of dark energy that we postulate in physics appears to be fine-tuned to 1 part in 10 to the 120th power. So in other words, I'm trying to explain to you what this is trying to say is the expansion rate of the universe is absolutely perfect. It's perfect to get life. If it were any slower in the beginning, you crunch back together. If it's any faster, you don't get the high energy collisions you need to get supernova, to get heavier elements, and you end up with just this hydrogen helium universe that's just gas, no life. So the expansion rate of the universe is absolutely perfect. This example is probably a little more relatable. Let's talk about Earth's place in the universe specifically, both in our solar system and in relationship to the Milky Way, our galaxy. Well, it turns out that the size of the Earth is perfect to support life. We talked earlier about gravity, how the force of gravity is just right to support the variety of life that we see. But if you could imagine, for example, if Earth was the size of Jupiter, much, much bigger, even with gravity, the constant, the way that it is, I'd be doing this number in my chair. We'd all be really squeezed down. There'd be very big physical limitations on advanced life. In fact, we wouldn't exist if we were on the surface of Jupiter. Even if Jupiter were habitable, I put this in habitable, if it looked like the Earth, it was as far as the Earth was from the sun, for example, and that could work physically, which there are problems with that. But anyway, waving my hands here, if we could do that, you wouldn't have life, advanced life like you have it. You'd have maybe microscopic life. You might, if you had water, you'd have certain things, but you wouldn't have advanced life because gravity, even though the constant would be fine, that would be too much mass, and it would keep people from existing. Another part of this, the moon is really important. When we talk about fine-tuning, the moon is a great example of fine-tuning. The moon supports the Earth's axial tilt. So the Earth is tilted, and that's what makes Earth climate, one of the things that makes Earth's climate stable. The moon supports that axial tilt. The moon does other really important things. The moon runs the tides, helps provide the energy for tides, and that helps currents through the oceans and stuff like that. And that is what helps also moderate the climate of the Earth. Our water cycle is incredibly important, and the moon and the positioning of the moon, the size of the moon, the impact that it has on our Earth's surface is just right. If it were much closer, there'd be catastrophic tsunamis all the time and really high waves. If it were further away, it wouldn't moderate the surface of the Earth enough. And so the moon, it's very important. Its size and its location, very important. Also, the moon protects us from asteroid strikes, comets, and the like. And so, we have all these things out in space that hurtle towards us, and you've got, popular movies like Armageddon that talk about what happens if an asteroid comes at the Earth. Well, thankfully, we don't have to deal with that very frequently, and the reason is because the moon protects us from a lot of those things. It acts as a buffer, sort of shoot things away from us. It's very interesting how the dynamics of that work. We've already talked about this briefly, but the sun is what they call a yellow star, and it is the right kind of star to support life. It doesn't throw off, tons of nasty radiation that could harm life. There are many stars out there that do that frequently throw out nasty radiation all the time, and you're not going to find, we don't think, or not likely to find life around those stars because of the dangerous radiation. It also turns out that the Earth is in the right zone in its orbit around the sun to support life. And I mentioned briefly in a prior session how no planetary orbit is perfectly circular. They're all slightly elliptical, or in some cases they're very elliptical. But the Earth has an almost circular orbit. And again, there's nothing about the natural world that dictates that the Earth would have an almost circular orbit. There's no reason why that should be the way that it is. There's no scientific explanation for it. It just is. Here is an image from NASA that shows the Earth in relationship to other possible planets that could possibly support life. And they're showing how far away from these different kinds of stars you have to be to support life. And there are narrow bands. And they're well known. We understand them. And so there are planets out there that look like they could be habitable to some degree or another. And it just turns out that the Earth is in the middle of what they call some people call the Goldilocks zone. It's just right. It's just right. And if we were much closer or much further away from our sun, We don't get the same impact. All right, I want to transition now to properties of carbon in water. Our first example is carbon. As I mentioned before, science fiction likes to deal with what about silicon-based life, or what if we could base life on another element of our periodic table, or maybe even on an element we haven't discovered yet. But there are really major theoretical difficulties with this. As far as we understand scientifically, carbon is the only element that's capable of producing genetic information like DNA and RNA. It's the only one that can support life like that. Carbon is it. That's why carbon-based life forms, that's all we see. It's all we plan on seeing scientifically right now, unless something crazy happens in chemistry in the future. Carbon can store more genetic information than any other element. It's preferential on every single level. So carbon, the existence and properties of carbon seem finely tuned for life. What about water? Water has tons of interesting properties that make it uniquely suited to support life. First of all, it's a universal solvent. When you do your dishes, you sometimes will soak your dishes before you get in there and scrub, because the water gets in there and it's a solvent. It dissolves those materials, that food. Another fascinating thing about water that's unique is that frozen water is less dense than liquid water. This does a couple of cool things. Number one, it preserves life in ponds. If you can imagine, if you had a thick blanket of ice that suddenly just sort of like fell, you would kill a lot of life there at the bottom of ponds and lakes and things like that. The other thing that frozen water, ice being on the top of these areas, is that it makes the water cycle more efficient. So you get that water back in the air, back recirculating, and keeping the surface of the earth more moderate. Talking a little bit more about the water cycle. The water cycle is what allows water to moderate the temperature of landlocked regions. So the fact that we have rain and we have snow and we have evaporation and condensation, all the different aspects of the water cycle, it allows areas like, for example, the middle of the United States. It's not uninhabitable because of the water cycle. The middle of the Eurasian continent, it's not completely uninhabitable because of the water cycle. Without the water cycle, those areas would be uninhabitable. You wouldn't be able to do that, to live there, because there wouldn't be enough water to survive, for living things to survive. There's a specific property of water called latent heat, and the fact that it has a high latent heat allows small bodies of water to not evaporate so quickly. It's what keeps water from evaporating very quickly. And because small bodies of water exist, they can support life all over the place. That's why you have small ponds that can support little small ecosystems and things like that. So the high latent heat of water seems to be helpful for life. Here's a final example. Surface tension. Well, it allows for fun activities like water skiing. So the one thing about fine tuning that I enjoy is that some of this stuff is it makes life enjoyable, it makes life fun, or there's some beauty to it. And so anyway, this is sort of a joke here about allowing for water skiing. But more importantly, surface tension allows for capillary action, which is how water gets brought into plants. So there are very specific properties of water that allow life to exist. I want to talk a little bit about beauty in math, physics, and nature. Here are some famous equations I put on the board. F equals ma, force equals mass times acceleration. E equals mc squared, Einstein's equation. This last one is force equals the gravitational constant times two masses, and they're thinking about two extraterrestrial masses, divided by the distance between them squared. This is a Newtonian way of looking at the universe. And it's still true other than relativistic situations. But the question is, why are these elegant equations true? Why isn't E equal a whole alphabet of numbers, letters and numbers? E equals mc squared, F equals ma. There's an unnecessary beauty and simplicity and elegance in mathematics and physics. That doesn't need to be the case. And that has caught the attention of lots of people, including skeptics. They can't explain why are these things true. Nature. Why are things beautiful? Just because life exists, life doesn't have to be beautiful. But we look around us and nature is just beautiful. And again, there's no reason why life would have to be beautiful. And yet here we are, we live in a world where we can perceive all these different colors and where life exists in so many different ways, and it's just beautiful. And it's just like, why? It doesn't have to be this way. We take it for granted, but it does not have to be this way. A powerful example of this can be found with eclipses. The apparent size of the moon and the apparent size of the sun are essentially identical. And there's no reason for that. There's absolutely no scientific reason why it has to be that way. And because the apparent size of the sun and the moon are essentially identical, we get eclipses. And because we get eclipses, we get something that is beautiful, that we can observe and helps us keep time and history and things like that. But it also has led to a ton of scientific discoveries because we can watch light bending around the moon, for example, during a solar eclipse. But just look at that. This doesn't have to be this way. There's nothing about physics that requires a habitable sun and a habitable planet and a moon that's helping that habitable planet for the apparent sizes of that moon and that sun to be the same. There's no reason for that. It doesn't happen on any of Jupiter's moons. It doesn't happen on any of the other moons we observe. It happens to our moon. It's just beautiful. And there's no reason for it. So, at the end here, I want to talk about how do atheists respond to fine-tuning. If fine-tuning is so powerful, then why isn't everyone a theist? Why doesn't everyone believe in God? Well, there's a couple of responses. We're going to be brief here, and if you want to research this more, I'll give you some good places to look. But the first response is the weak anthropic principle, which is what Richard Dawkins uses. And basically what the weak anthropic principle asserts is that we would not be here having this conversation if the universe wasn't the way that it was. So we don't have to explain it. We're showing up on the scene late to the game. We don't have to explain anything. We're here to have the conversation, and that's all that needs to be, there's nothing that needs to be explained. Christian scientist Stephen Meyer says, in response to this, in essence, the weak anthropic principle wrongly asserts that the statement of a necessary condition of an event eliminates the need for a causal explanation of that event. Then he gives an example about oxygen and fires. So just because oxygen exists doesn't mean that oxygen can explain why a specific fire took place. So he says oxygen is a necessary condition of a fire, but saying so does not provide a causal explanation of the San Francisco fire. Similarly, the fine-tuning of the physical constants of the universe is a necessary condition for the existence of life, but that does not explain or eliminate the need to explain the origin of fine-tuning. So what are other responses to fine-tuning? Victor Stenger is a physicist. Richard Dawkins is a zoologist atheist. Victor Stenger is a physicist atheist, and he attacks fine-tuning from several different directions. He argues that carbon, for example, is a natural consequence of the scientific order. But then he flips fine-tuning on its head and he says that because of what we know about fine-tuning, most of the universe is uninhabitable. We talked about the Earth being in the Goldilocks zone and being in the right place for this and the right place for that. Well, maybe the universe isn't as fine-tuned as we thought, because we should see life everywhere if the universe is finely tuned, according to Victor Stenger, but we don't. So maybe it's not as finely tuned as we thought. So how do we respond to Stenger? We can say that carbon still came from nuclear reactions as given by the conditions of the laws of physics we have. And like I said before, what we know about physics, what we know about chemistry, is that it could have been very different. And so the fact that carbon comes to us in the proportion it comes to us and with the properties that it has, it's still governed by those initial conditions of the universe. And it could have been a number of different ways, and those number of different ways still lead us down no life. And the other thing that he says is the universe is a great waste of space. But I would say as a theist, as a Christian specifically, that the universe is not a waste of space. That it tells the story of God. And it's a place for us to explore. And so a lot of Christian thinkers throughout time have loved looking to the stars and studying things. And so there's no reason to say that the universe is a waste of space. That's oversaying it, overdoing it. If you want to dig into this deeper, there are 3 further objections to fine-tuning. And I highly recommend, if you want to get into philosophy of science, Jeffrey Kopersky's book, The Physics of Theism. It is deep. If you want to get deep into this problem of fine-tuning, this is the place to go. Physics of Theism. So there's 3 further objections to fine-tuning. There's what's called the observational selection effect. Basically, what that's saying is, they use the analogy of a net. If you go to a pond and all you find are fish that are longer than 10 inches, how do you actually decide that all the fish in the pond are 10 inches or longer? How do you decide the probability? Well, if you have a net that's 10 inches big or bigger, then you can only catch fish that are 10 inch big or bigger. But if, there's a hole there. But if the way that you're going to the problem is that you're filtering out all the smaller fish, you're never going to find these other possibilities or probabilities. And so they attack fine-tuning that way. Another way that people attack fine-tuning is problems with probability. They say, if we have an infinite number of possibilities, the total probability has to add to 1. But if you have an infinite number of possibilities, how do you get, using the understanding of infinity, how do you get a probability that adds to 1? You don't. You get a probability that adds to infinity. And so there's this mathematical issue with these fine-tuning, saying that that these things are finely tuned to 1 part in whatever probability you want to give. So they attack it using mathematical theory. The other option we have is naturalistic explanations. We have, for example, future physics may solve all these problems. Dawkins and Stenger both believe in an infinite number of universes. So they believe in this naturalistic explanation. They believe that there's just a way that we can get to a perfect universe, because if there's an infinite number of universes and this universe is infinitely improbable, then that math works out again. You get one universe that can support life. That's how they get there. So there are ways around fine-tuning. And if you want to get into the weeds, again, I recommend The Physics of Theism. If you don't want to get into the weeds as much and you want to talk about some of the examples that I've talked about in this session, I highly recommend The Privileged Planet by Gonzalez and Richard. There's a book, and if you prefer documentaries, there's a documentary version of it as well. And I highly recommend, if you want to dig into more about fine-tuning, The Privileged Planet. It's a great resource. So as we conclude our session on fine-tuning, what does fine-tuning say about the existence and nature of God? After we've observed all these crazy coincidences and how we get to the point of having a universe that can support life, a Milky Way that can support life, a solar system that can support life, a sun, an Earth that's in the right spot with the right orbit, the right tilt, has a moon protecting it, all these different things. When we think about all these different things that we've observed from science in this session, what does that say about the existence of God? Well, this is what I think, and you can feel free to come to your own conclusions. I believe that the universe was fine-tuned for life. I think that when you look at the scientific evidence, that's what you'll see. I don't think that this is necessarily direct evidence for God. I think it absolutely points right at a creator, though. I think the existence of God, we have to decide what fits this evidence better than any other explanation. Is it that there's an infinite number of universes? Is it that we have a creator? Sort of which option do we have? Is it the chance? Is it that we just sort of luckily happen to have a perfect universe? Those seem to be our 3 options. We have chance, we have design, and we have this probabilistic way of reducing the problem to, getting it to happen. So those are our 3 options. We've got those 3 things. And I think the best fit for this evidence is that God exists. That God exists, that he's the one who created the universe for life. And I think that tells us something about the nature of God as well. I think it tells us that he cares about life, that he cares about a relationship with his creation. And if you look at the various options, the various gods out there, again, I think the Christian God fits that criteria the best. And I know I'm hand-waving a lot here at the end of the session. Go into it, look into it yourself, see what you think about it. So that's just a little bit, scratching the surface about fine-tuning. Thank you.